welcome to Unacademy, India's largest online learning platform, which is helping the students of all corners of India to improve their learning skills and to crack the GATE examination and all other examinations and to realize their dreams. Any student from any corner of the country is able to learn from the best of the best faculty members of India to improve their life. This is the best opportunity given by Unacademy. Please utilize this opportunity to realize all your dreams. To realize all your dreams. So very important, sir. Very important. Welcome to Unacademy. So this is a crash course on analog electronics. This is a crash course on analog electronics. So we will be trying to finish this course before 31st of this January, so that the students who are attending 2021 GATE can get success in their life. Okay, now I wish you all a happy Kanama. That is the third day of Sankranti, so which is celebrated especially in South India as the biggest festival. Hope this Sankranti brings happiness and prosperity to all of you. Happiness and prosperity to all of you. Okay, now we'll move on. So we are discussing a subject called analog electronics, which will be useful for the students of electronics and communication engineering, electronics and electrical engineering, and then instrumentation engineering. So this will be useful for the students who are preparing for GATE and ESE also. So this is a crash course. Now the today's topic is going to be bipolar junction transistor part 4. Bipolar junction transistor part 4. Okay. So myself, Shravan Kumar, I have master's degree from JNTUH in VLSI system design. So I have 10+ years of teaching experience, and I taught thousands and thousands of the students in my teaching experience of 10 years. Okay, now I can teach a subject called EDC, sir. 40 classes, 40 hours of EDC I have already taught on YouTube. And YouTube right now the remaining classes I am teaching on Unacademy app, and now I started a crash course on analog electronics. It's a crash course, so which will be finished before 31st of January. So that the students who are preparing for 2021 can also get benefited out of it. Of course, in this crash course, I can't discuss 100% of analog electronics, but we try to finish it as much as possible. We will try to cover as much as possible so that you will get the maximum marks. So from EDC you can expect 10 to 11 marks, and analog electronics will get 9 to 10 marks. Almost 20 marks I am going to cover. So if you are able to cover another 15 to 20 marks in mathematics and aptitude, you are done with you can easily crack the GATE examination. I'm not talking about the topping. So I'm just talking about cracking the GATE examination, at least clearing the GATE examination. Okay, that would be possible just by listening my classes of analog and EDC, and then you will be given 1 minute. Just a second. No, nothing to worry. Okay, now somebody was saying something. Okay. EDC and analog, and this digital and EMEFT will target for 2022 or 2023. For both 2022 and 2023, we'll target this. Okay. Now I have a special code for you, something called SVS10. So which will help you to get 10% discount on Plus Academy subscription, plus subscription, Unacademy plus subscription. So what do you mean by plus subscription? In case of a plus subscription, so what you will get is you will be given an access to the live classes. You can attend all the crash courses. You can write all the weekly tests. So sir, time and again I'm mentioning this. Writing the test is very important. Gate is not just about what you listen. Gate is all about what you write, right? So always better you should write a gate exams, continuously gate exams, and so that you will improve yourself. And you'll have another session called doubt solving session. So every 4th hour is going to be doubt solving sessions. You can have a very good interaction with the faculty member. Very good interaction with the faculty member, right? So the interaction would be either in English and Hindi. The classes will be English and Hindi. Those who are unable to understand Hindi, they can listen to English. Those who are unable to understand Hindi, they can listen to English. Those who are unable to understand English, they can listen to classes in Hindi, right? Right? Oh, and we have another special thing called rank improvement batch. So what is the advantage of this rank improvement batch is somebody who is having some good percentage of marks and so some good knowledge in the basics of the subject, and they got some good rank. Let's say they got some 2000 rank or 3000 rank or 10,000 rank. So if they want to decrease their ranks to two-digit rank, they will be given a special coaching called rank improvement batch. They'll be given a special coaching called rank improvement batch. Okay. So these are the benefits of a plus subscription. Along with plus subscription, we have another subscription called iconic subscription. We have something called iconic subscription. So what are the benefits of this iconic subscription is you will be given definitely you will be given a personal coach. This is very important, and you will be having a study planner. You'll be given a study booster sessions, and then we'll have something called personalized test analysis. And we'll have something called preparatory study material. Preparatory study material will be also important, which is very important. While when exam comes closer, this material plays a major role. So what are the fee structures for subscription is? You'll have a plus subscription. For plus subscription for 12 months, you are going to have a 27,225 rupees as a fee structure. And for 18 months, it's going to be 34,650 rupees. For 24 months, it's going to be 39,600 rupees. 39,600 rupees. Okay. Now you will have a SVS 10 as a promo code for all the three to get 10% discount. Similarly, you are going to have something called iconic subscription. For iconic subscription for 12 months, you are going to have 45,225 rupees, and for 24 months, it's going to be 66,600 rupees. And SVS 10 is a promo code. SVS 10 is a promo code to get 10% discount on any one of the iconic subscription. Okay. So how you will get it, sir? Subscription. Simply you should download the Unacademy app. You know how to download the Unacademy app. Simply go to Play Store, download Unacademy app, install it. After installing, you have to choose your goal. So as I told you, our wings are into many things. NEET, PG, GATE, NET, whatever exam is there, we are there. So you should choose GATE and ESE. And GATE and ESE, you have a click on plus subscription and click on get subscription. Once you click on get subscription, you will be taken to another window which is having duration of the subscription. Either you are going for 12 months or 24 months. So if you are going for 24 months or 12 months, don't forget to use this code SVS10 to get 10%. Very important, sir. Very important. SVS10. SVS10 is a 10% discount. You'll get 10% discount, right? So and just click on apply. When you click on apply, so you will be given you will be taken to the payment mode. So you have different payment methods. You can use a debit card, credit card, EMIs, UPIs, wallet, net banking. So all these things are important. Just click on that. So once you select it, you will be taken to the payment and you will be paying it. Okay. So I request all of you to follow me on Unacademy. So this is my Unacademy code. All I request is Just follow me on Unacademy. All I request is follow me on Unacademy. So we will just see what we have discussed in the previous class. So in the previous class, what we have discussed is we have discussed what is the definition of small signal amplifier. What is amplifier? See, the basic function of amplifier is to do a faithful amplification. It has to do a faithful amplification, which is very, very important. So faithful amplification is more important. And then, so we have seen H parameter model. So how H parameter have come. So for a two-port network, you have Z parameters, Y parameters, and H parameters. So Z parameters are I also called as impedance parameters. Y parameters are called admittance parameters because all the units of the parameters of Z parameters are ohms. That is the reason they are impedance. They are called impedance parameters. All the units of Y parameters are called are having mhos. That is the reason they are called admittance parameters. Whereas H parameter is a combination of both impedances. So which is having impedance. So it can have a mhos, ohms, and dimensionless qualities. So because of this mixed behavior, they are called as H parameters. They are called as H parameters. They are called as H parameters. Okay. They are called as H parameters. And we have seen how the H parameter model looks like. This is a common emitter configuration. This is a common emitter configuration where you will have an input voltage and source and our load resistance, and we will be replacing this transistor by its equivalent model. Now these are the different configurations: common emitter, common collector, and common base. And we have discussed in detail how we got this. And I think we are discussing this, and we'll see today's class. Now you can see here. So the parameters HI is nothing but input impedance. I can call this as input impedance. Input impedance. I'll write input impedance. And HR is nothing but a reverse voltage gain. HF stands for forward current gain. This is output admittance. The inverse of output admittance 1 by H naught. Inverse of output admittance 1 by H naught is called output resistance, or actually output impedance. You can call output impedance. Okay. Now if you look at all the values, these are critical values. We call them generally. We call all these things are critical values. So if you look at all these critical values of common emitter, common collector, and common base. First, we'll see what is common emitter and common collector. For common emitter and common collector, this is going to be HIE. This is going to be HIC. So you can see here HIE is almost equal to HIC. So HI is equal to almost equal to HIC. But HR is not same. But for common collector, HRC is unity. What is HRC, sir? Voltage gain. So voltage gain is going to be unity. What is going to be unity? Then here, what is this, sir? HF. So HF is nothing but I can also call this as a beta. You can also call it this beta. If you look at here, for common collector, it's going to be minus of 1 plus HFE. Yes or no? So I can also call as minus 1 plus beta. And H naught are same. What is H naught, sir? What is H naught, sir? So can I call this as R naught? So output resistances are same. It means output admittance. Both of them are same. What is this, sir? HOE is same as HOC. So for common collector and common collector, all of them are same except this voltage gain. But the voltage gain for a common collector is going to be 1. Is going to be a unity. Now if you look at this, common base, look at this common base configuration. So this input impedance is very low, sir. Yes or no? So when compared with these two, common emitter and common collector, input impedance for common base is low, because you can see here it's 1100 for common collector and common base, and for common collector and common emitter. For common base, it's going to be very low. It is 21.6. So common base has a very low input impedance. Very low input impedance. Now, if you look at this voltage gain, look at this voltage gain is going to be 2.5 10 to the power of minus 4. It's going to be 2.8 10 to the power of minus 4. So this is also not useful for voltage gain, right? Voltage gain is reverse voltage gain. Reverse voltage gain, sir. So this is going to be reverse voltage gain. So what is forward voltage gain? If you want to calculate, forward voltage gain, what is going to be, sir? It's going to be 2.5 by 1 by 2.10 to the power of 4 by 2.5. So 10 to the power of 4 by 10 to, let's say 10 to the power of 5 by 25. So it is going to be how much, sir? It's going to be how much? So something around 4. It is going to be 4,000. Let's say 400 means 400 kind of thing you'll get. 400 kind of thing which you'll get. So here also you'll get almost same. So but this voltage gain for a common emitter is high when compared with common base. But whereas for common collector, current gain is going to be only unity. Voltage gain is going to be unity. Now if you look at this, current gain. So now earlier just now we discussed a common emitter can be used for voltage gain also. A good voltage gain is also available. Good current gain is also available. For common emitter, voltage gain, voltage gain and current gain, both of them are available good. But whereas for common collector, voltage gain is unity, but current gain is also existing. Current gain existing. If you look at this common base, it is almost unity. So the current gain for a common base is almost unity. Of course, it is the minus. Minus indicates that they are opposite in direction. That is, input current, output current are opposite direction. Input current and output current are in opposite direction. That is, they are not same. They are not same. Okay. So now beta is going to be almost same for common collector and common emitter. So now if you look at here, so common emitter has both voltage gain and current gain. So most of the times we will discuss about only common emitter because it has both voltage and current gain. Because we always talk about the amplifier model of a amplifying model of a transistor. So the best amplifier is going to be generally common emitter because it has both voltage gain and current gain, right? And you can see here output impedance. Look at the output impedance. It will be 40k and 40k, but whereas the common base has the highest. Common base has high output impedance. So which having high output impedance. Remember this: low input impedance, high output impedance is there for common base. So for common emitter and common collector, the input impedances and output impedances are almost same. So HOE is almost equal to HOC. HOE is almost equal to HOC. Okay. Is the point clear? Okay, now we'll go to the next slide. So this is the conversion formulas. These are the conversion formulas for let's say if let's say I'll also write here common emitter. For common emitter, you're going to have input impedance HIE is going to be HFB. Sorry, this is not HF. It's going to be HR. HRE. It's going to be HFE. It's going to be HOE. Assume that these are given. Okay. So then why we are considering this as? Because in general, what will be given, sir? As I told you just now, common emitter is a majorly used configuration. So because of that, this HIE, HRE, HFE, and HOE will be given. So in some cases, he will ask you to calculate. He asks you to calculate the values of H parameters of common collector and common base. So, but he will give you the values of common emitter. So in that case, So this table is very much important. So, but remember, just now we discussed, so in most of the cases, for common collector and common emitter, and common collector, both of them are almost same. Look at here, So HIC is equal to HIC, so no change, and HOC is equal to HOE, so no change. If you look at HFC simply minus of 1 plus HFE. So almost I can also consider this going to be HFE, but is in minus. This is minus. Remember that. Let's say if HFE is equal to 100, so 100 and 101 doesn't make any big difference. Doesn't make any big difference. Right? So almost HFC is equal to HF minus HFE. HFC is equal to HFE. So now let's come back to the important things of the common base configuration. Sir, only one thing what you need to remember is blindly except HRE, except HRB. For all other cases, it is very simple, sir. Just divide by 1 plus HFE. Just divide by 1 plus HFE to get HIB. What I mean, sir? HIB is equal to simply HIE will get, right? HIE by 1 plus HFE. So that is nothing but 1 by something HIE by 1 plus beta. So divide all the parameters. So I mean to say HIB, HFB, and HOE. For all these three parameters, first divide by HFE. So we have only problem with this HOE, sir. So remaining all the three are almost same. The only thing is you have to divide it. So for common emitter to common collector, all the three are same. For common base, yes, all three are same except they need to be divided by 1 plus HFE. All three parameters need to be divided by 1 plus HFE. All three parameters need to be divided by 1 plus HFE. This you have to remember. So very important. This you need to remember. So all the three parameters must be divided by HFE. It's 1 plus HFE. Now, if you come back to this HRB, so you'll have, I'll try to write this HRE in a different way. HRB is equal to minus HRE plus, again you need to divide by something plus HFE. So when HRE is there, what are the remaining, sir? You have HIE and HOE. HFE is already there. HRE is already there. So the remaining two parameters need to be written here in the numerator, and 1 plus HFE is need to be written on the denominator. This is just a blind thing I'm just trying to explain you so that you will not get confused, or it will be useful even in the examination. Useful for you in the examination. How to remember? Okay. So HRB is going to be minus of HRE plus divide by 1 plus HFE, and in the numerator. So the remaining two parameters. What are the remaining two parameters, sir? HIE and HOE. You multiply them. Simple. So these are the conversion formulas will be there for all the three configurations. So here, after analysis, the most important things need to be calculated here. So I'll try to draw a table so that you will have a. This is after analysis. Actually, I'm not trying. Yeah, this is a crash course. I'm unable to discuss in detail. About all these things. These are going to be parameters. This is going to be common emitter. common emitter, common collector, and common base. So this is very important, sir. This is going to be a parameter. I'll write with some other. It will be parameter for common emitter, common collector, and a common base. Common basis, right? This is going to be, I can call this as analysis. Analysis. So analysis table, I can say. Analysis table, I should say. Analysis table. So for common collector, what is the input resistance, sir? It is as simple as HIE actually. HIE, but something will be added. This is very less in actual value, but it's going to be 1 plus HFE, 1 plus HFE into the RE in parallel with RL. What is RE, sir? Emitter resistance of common emitter configuration. Emitter resistance. Or in common collector, if RE is considered, because you will collect output across load resistance, right? Output across this RE, right? Emitter terminal. So that RE must be considered. That RE must be considered. So that is important. Then what is current gain? Current gain is simply when it is minus of HFE, it is minus of minus 1 plus HFE, right? So minus of minus 1 plus HFE. It's going to be simply 1 plus HFE. 1 plus HFE. I can also call it's going to be 1 plus beta. I can simply call 1 plus beta. Sir, as this is a crash course, we are unable to derive all these formulas. In a normal course, what we'll do, sir, we'll try to derive all these formulas. We'll try to derive all these formulas because as it's a crash course, I'm unable to derive all the but we'll discuss all of them in detail when we are discussing about a regular course, right? So then what is the voltage gain? What is the voltage gain for common collector? It is same, sir. If we can able to calculate the current gain, so it's going to be simply current gain into RL by RI, as same as that of that, right? So here for common collector, what is the output resistance? Sir, output resistance is bit different. So it's going to be HIE input resistance by 1 plus HFE 1 plus HFE. See what I'm writing. It will be 1 plus HFE. Bit not sufficient, but you need to consider the source resistance RS also. You need to consider source resistance RS also. You need to consider source resistance RS also. You need to consider source resistance RS also. Okay. Now we'll come to common base. For common base, what is the input resistance value is going to be? Input resistance value is going to be, that is input resistance HIB. HIB is going to be what, sir? It's going to be simply HIE by 1 plus HFE. 1 plus HFE. Any change, sir? No change. No change. And what is HFE? HFB. So if it is going to be HFB, so minus of minus will get, or I can write minus HFB. I can write minus HFB. I can write it's going to be simply HFE by 1 plus HFE. 1 plus HFE. 1 plus HFE current gain. But sir, what is the current gain formula? Alpha. Simply alpha. Yes or no? Alpha. Yes or no? Alpha. What's the value of alpha? Alpha is less than 1. This is HFE by 1 plus HFE. So 1 by 1 plus 1, let's say, if you say HFE is 1, 1 by 1 plus 1. So almost alpha is equal to 1. Almost alpha is equal to 1. Yes or no? Almost alpha is equal to 1. So that is what common base current gain. In common base voltage gain, no change, sir. So once you can able to calculate current gain, always remember the voltage gain is very simple. If you have to calculate current gain, then you get RL by RI. Voltage gain can be very same. Voltage gain can be very same. Then what is output resistance for common base? So remember always this need to be infinite. For common base, output resistance is going to be infinite. Output resistance is going to be infinite. This is a very important point to be remembered. Just a second. Okay. this is what about the analysis table. Next, we have another model called RPI model. Sir, we have another model called RPI model. So in this RPI model, you can see this resistance. This resistance is called as RPI. This resistance is called RPI. This is pi model. So far, what we discussed is H parameter model, and this is also same as that of the model. So as I told you, there are 3 to 4 models in case of a normal PN junction diode. What are the 3 different models which we have discussed in a normal PN junction diode, sir? In a normal PN junction diode, what we have discussed, sir, you have a piecewise linear model, ideal model, approximate model, like this, right? Simplified model, like that. Similarly, here also we have 3 different models: H parameter model, RPI model. I think I have another model called RE model also. RE model also. So in this case, you can see here. In this case, you can see here. This is almost as same as that of the previous H parameter model. What happens in H parameter model? Acha, it is not there here. Okay. We'll see it later. We'll see in a comparison. We'll see for all the 3. For this H parameter, RP and RE model also we'll discuss. So we will discuss all of them. We'll discuss all of them. Okay. So this is going to be RPI model. In case of RPI model, you can see the input voltage is going to be VBE. Input voltage must be considered as VBE, and the corresponding resistance is going to be RPI. So can I call input resistance as RI? RPI input resistance can be called as RPI, and you can see here GM. GM is what, sir? GM is, always remember, GM is transconductance. GM is transconductance. You can easily imagine what is going to be transconductance. Really, what do you mean by conductance? What do you mean by conductance? How will you measure the conductance? Conductance is the reciprocal of resistance. Yes or no? It is a reciprocal of resistance. Reciprocal of resistance. Remember this. Okay. So how will you get? You'll get it from the calculations, right? And whereas R0 is going to be output resistance. It's going to be output resistance. But simply, what happens, sir? For the many cases, so what happens is this output resistance is a dynamic resistance. Actually, output resistance is going to be dynamic resistance. So which will get from output characteristics. Yes or no? Output resistance can be calculated from output characteristics only, right? So how the output resistance can be calculated? If you look at the output resistance, so output resistance are not need to calculate. The output resistance is always if you look at the output characteristics of common emitter configuration, you might have seen, you'll get like this. The output characteristics will get like this. So what are the output characteristics? You are going to have VCE, common emitter, right? Common emitter. What is the output current? Output voltage? What is the output voltage, sir, for common emitter? VCE only. VCE. And what is current? Output current? IC current. What is current? IC current. So now what I need, sir? I need resistance. I need a resistance. Resistance means what, sir? Actually, what resistance? So R is going to be V by I. V by I means here what is R? R is an x-axis. I is an y-axis. So can I call this simply y by x? So this R is going to be 1 by m. What is m stands for? 1 by slope. Yes or no? 1 by slope. So this R0, the output resistance, will be given by 1 by slope of the output characteristic curve. 1 by slope of the output characteristic curve. So 1 by slope of the output characteristic curve. So if you look at here, that is generally what we'll call, sir. So changing output current with respect to changing input voltage. with respect to change in input voltage, right? So for small change in input voltage, is there any so this value will be very high. The slope value will be very small. There is no value of very small. So when the slope is very small, so R naught is almost equal to infinity. So when R naught is equal to infinity means it is having high resistance, high output resistance, high output resistance, high output resistance. So high output resistance. So generally what we'll consider, sir, is going to be open circuit. Will consider open circuit. We will consider open circuit. Will consider. So when you consider it's open circuit means open circuit means R naught is going to be 0. That is, this is like you'll get like this. Anyway, we'll try to draw this again. So just a second. So to draw the previous case. So what is the previous case, sir? I'm sorry. So simply this R naught should be open circuited. It means so the simplified RPi model is you will have a resistor here and you will have a current source, simply dependent current source, and you will not have anything else. You will not have anything else. This is going to be base. This is going to be emitter. This is going to be collector, and there is some current is flowing, which is nothing but GM into the input voltage. What is input voltage, sir? Is going to be VBE. The resistance is going to be R pi. This is going to be R pi. So GM into, can I call simply VBE, and this current is flowing is IC current. IC current is flowing here. So what is the output current? Output voltages is nothing given. So this is what simply a simplified model of a RPi model. This I can call this as RPi model. RPi model. RPi model. So what unknown things you don't know? RPi and GM. RPi and GM. So RPi is very CM, sir. Very simple. RPi is going to be beta by GM. So R pi, remember this formula is going to be beta by GM. Beta by GM. So what is GM then? How to calculate GM, sir? Simple, sir. GM is equal to, you know, to important, remember this point, very important point. So GM is equal to DC current IC by VT. So how will you calculate the IC current? How will you calculate the IC current? Very simple. By using DC analysis. By using DC analysis, you can calculate DC analysis. By using DC analysis, you can calculate the value of IC. So we will be knowing VT. Generally, VT will be 25 millivolts, or somebody may say it's going to be 26 millivolts. So this is going to be constant. Now you can calculate the value of IC very easily. When you calculate the value of IC very easily, or if you given, so you can calculate GM. If you know the GM, you can calculate R pi. I will calculate R pi. R pi is going to be beta beta by GM. GM you have calculated. Beta is constant. Beta is constant for a given transistor. Beta is constant for a given transistor. So it's going to be R pi is going to be beta by GM. R pi is going to be beta by GM, where GM is going to be IC by VT. So what is IC? DC current. What is DC collector current? DC collector current. So I will calculate, sir, by doing some DC analysis. Anyway, don't worry. In coming classes, we'll discuss some problems so that you'll understand this. You may think that why I'm discussing all these things. Very important. That is the reason why I'm discussing all these things. Okay. Next, another model called RE model. In RE model, so in RE model, it's almost same as that of RPi model. RPi model, but only difference is you can have a base, emitter and collector same. So I think here some mistake has happened. I mean to say this is 1 plus beta into RE, sir. 1 plus beta into RE. 1 plus beta into RE. 1 plus beta into RE. So it is as same as that of this previous RPi model. If you look at the RPi model is this. So if you want to drag like this, you can say simply emitter here, same resistance you have, same current source, same resistance, output current, output resistance, same. So but here we have beta into VB. There we had GM into VBE, GM into VBE, GM into VBE. for that. GM into VB for that. So now here, what you don't know, sir? You don't know what is the value of RE. RE. So how did we calculate the value of R pi? R pi was beta by GM. R pi by beta by GM. That is, if you substitute this GM, it's going to be IC into VT. IC into VT. Right? So we know that R pi is going to be sorry. So beta by GM, beta by GM. What was GM, sir? It is not beta by uh, uh, IC by VT. Yes or no? Yes or no? IC by VT. Yes. So, I'm sorry. Yeah. Unnecessarily I done that. Okay. IC by VT. So R pi is going to be. Can I write this as a VT into beta by IC? Beta by IC. So what is beta by IC? Is it not VT by IE, sir? VT by IE or not? IC by beta. Beta is equal to IC into IC is equal to beta times of IE. IE is equal to beta times of IC. IE is equal to beta times of IC. So now remember this point. RE is equal to VT by IE. VT by IE. This is very important. This is very important. So if you want to compare all the three, you can simply compare all of them. If you want to compare all of them, you can simply compare them. Now you can see here. Now I'm just trying to compare all the three. You can see here. This is a H parameter model. And this is what, sir? This is R pi model. And this is RE model. So don't think that I have to discuss anything in detail because this is a crash course. I can't discuss all those things required because next we have op amp to be discussed. A very important concept, op amp. Op amp is also very, very important concept. So I have to discuss that point also. Op amp, at least we need to spend 7 to 8 hours on op amp because op amp problems are definitely will be given 2 to 3 marks. Definitely 2 to 3 marks will be there in the examination. Sometimes even he will give you 4 to 5 marks also op amp. So I have to calculate. I have to concentrate more on that. Okay. So one more important thing which I missed here in this case here. So here also that R naught is very high. R naught will be considered as very high. R naught is very high. So R naught is going to be very high. So it means R naught is going to be infinite. It is infinite. I will represent with open circuit. So the another equivalent model for RE model is going to be you're going to have is going to be RE, and again you will have this is neglected. This is going to be base. This is going to be emitter. This is going to be collector. This is also emitter. This RE can be neglected, sir. RE can be neglected. You'll have current IC. You have current IC, which what we have written, sir? What we have written? So I is equal to beta IB. So yes or no? Yes, sir. Beta IB same value. So what is this? This is going to be RE. What is that RE? RE is going to be 1 plus beta into RE. 1 plus beta into RE. This is going to be emitter. This is going to be emitter. This, sir, we are all discussing only for common emitter configuration. You know why? Common emitter configuration is the mostly used configuration. Because of that our discussion is more on common emitter configuration only. 2 points you need to remember here is R is going to be VT by IE, R naught is 0, R naught is open circuit, infinity, R naught is going to be infinite, R naught is going to be infinite, right? If you look at all these three, and even if you forget even if you forget this, let's say R0 is not there, this R0 is also not there, R0 is also not there. So what you can see here, this is the input resistance HIE. So for H parameters, HIE is going to be input resistance HIE. So what is input resistance for RPi model? RPi model input resistance is, what is the RPi model input resistance, sir? Is that not RPi simply? It will be RPi. So this is for H parameter model. This is going to be RPi model. And what is corresponding RE model? RE model, you can see here, what is that resistance? I'm sorry. So the input resistance same. So same current IB is flowing here, IB is flowing here, IB is flowing here, IC is flowing here, IC is flowing here. So now what is this here? Even this is also infinite. As well, high input resistance, high output resistance will be there, right? That's the reason why we also neglect this. So what is its RE then? What is the RE there? So RE is as same as that of 1 plus beta or not. So HIE for, so you can see here, in the H parameter model, HIE is the input resistance. For RPi model, RPi is input resistance. For RE model, 1 plus beta into RE is the model. Sir, you take any model, irrespective of the model which you are discussing, so these simple conversions will be there. Don't need to worry. We will discuss this problem. While discussing problems, you will understand this very clearly. Okay. You need not worry, sir. You need not worry. I am here to. If you do some problems, you'll understand this. Now you can also see one more important thing here. So what is HFE, sir? HFE, HFE, HFE. What is HFE? HFE is forward current gain. So what is current gain here? We have written GM into VB, but here HIE into some value IB here. I see here, IB is here. So how will you write this? Can I write this GM? GM is same. So can I write this VB by RB? VB into RB, VB into RPi. This RPi model. So can I write this? As GM into VBE? Can I write this as GM into RPi? That is what VB I am writing. What is VB value? VB is equal to RPi into IB or not? So if you look at this, this is same as that of HFE into IB. So now this is also same. GM into RPi. So the HFE is what we are talking is same as GM into RPi. GM into RPi for RPi model. GM into RPi for RPi model. GM into RPi for RPi model. Can now what is this, sir? What is there for RE? For emitter, what is RE model? So what is this? For RE model, what is this, sir? Simply you can see again compare. So HFE into IB, this is HFE IB, and here I have given GM into RPi into IB, here beta into IB. This is beta into IB, you can write this simply as beta or not. So HFE into, sir, most of you might be feeling very difficult. Yes, sir, this part of analog electronics is bit tricky. But once we do few problems, you will feel very comfortable. Need not worry. Are understanding or not? So once we finish this, all these things, once we do 1 or 2 problems or 10, let's do as many problems as possible. Let's do as many as problems. I need to balance op amp also, because op amps I need to discuss, oscillators I need to discuss, so feedback amplifiers I need to discuss. So for all those things, I may not time may not be sufficient. That's the reason why I'm discussing very quickly, right? So few problems we'll discuss. Based on this analysis, right? Very important problems we'll discuss. So mostly from previous gate problems only we will discuss, so that you will get confident enough of you'll get confident enough of the problems, right? So important thing is you need to do the analysis, AC analysis and DC analysis. AC analysis, DC analysis, that will do one problem. So probably we will discuss this in the next class, right? So we'll try to wind up here, and we'll see. So we'll see what we have discussed today. We have discussed comparison parameters of all common emitter, common collector, and common base. And then we have seen conversion. This is conversion table. I can use conversion table. Conversion table. This is very important. Conversion table is very important. Conversion table is very important. So even the conversion table also, it's very simple. CE, CC are almost same. CE, CC are almost same. Only thing is CB. For every CB, divide it with 1 by HFE. Divide with 1 by HFE. So HIB is equal to HIE by 1 plus HFE. HFB is equal to minus HFE by 1 plus HFE. HOB is equal to HOEB by 1 plus HFE. What is the difference? Nothing much. You not worry much. You not worry much, sir. You not worry much. Okay. So this is what we'll get. This is what we'll get. So, and we have discussed the analysis table. So the input resistance, current gain, voltage gain, output resistance, these are the 4 parameters generally asked in the examination. So once we do some problems, you'll understand this. This is RPI model which we have discussed in detail. The RE model we have discussed, and comparison for all these things also we have discussed. Okay. So coming to the point of again the plus subscription. So what do you mean by plus subscription is? So the benefits of plus subscription is you will be given access to the live classes. You can attend all the crash courses. So and you have tried weekly tests. So time and again I'm mentioning this, very important. So GATE is not just about you just listen to my classes. So you're listening to my classes may give you only 50% of marks. But another 25% you have to practice more number of problems. Another last 25% is discuss with your friends. Form a group who are very studious, who are very serious about GATE examination or ESE examination. You should become a group and keep discussing, sir. Don't think that that fellow is competition to you. Sir, no one is a competition to you at all in your life. Their way of living is different, your way of living is different. You are come from different family, they are also come from different family. So have a positive competition. Let's grow together. Right? So generally what we'll say, sir, so a plus b is a plus b whole square I'm talking about. So if let's say you are working with your full energy, you'll get a square. Let's say your friend is also working with his full energy, b into b square. But if you work together, what happens, sir? You'll get a square plus b square plus 2ab plus 2ab. So sometimes what happens is, let's say it's going to be 1 plus 1. 1 plus 1 square. What happens, sir? It's going to be 1 plus 1 plus 2. So almost it's going to be, so what you get, sir? You'll get almost a square plus b square is equal to be 2ab. Okay. So it is very important. So very important to get the point. So work together, form as a team. Request your friends to join with you, so that you can achieve the success in your life. You can achieve success in your life. Don't get disappointed, sir. Don't get disappointed. So we are here to help you. To see success in your life. So your success is our success. That is what our motto. Our motto is your success is our success. Okay. Next you are going to have doubt solving sessions. Every 4th hour you can interact with your mentor or teacher who is teaching, the educator. So you can clarify your doubts very clearly. Okay, and then the sessions will be English and Hindi. So somebody who don't know English, they can listen in Hindi. Somebody who don't know Hindi, they can listen in English. And I have told you what is the rank improvement batch. This also will help very well, sir. Many students got benefit out of this rank improvement batch. So you also get this chance of rank improvement badge. So and we have another subscription called iconic subscription. So what is the benefit of iconic subscription is all the benefits you will get plus subscription, and then apart from that you will be assigned a personal coach. So who will be guiding you for preparation strategy very clearly. A personal coach will be allotted, and then you have something called study planner. A customized study planner will be there to track your performance. So where you are lagging, where you are improving, which subjects you are not there. So and how to study very well will be given by study booster sessions. And very importantly, after every examination, you will be given in-depth analysis, section by section and question type. So this will help you to know where you are lagging. This will help you to know where you are lagging, and you will be given very importantly the preparatory notes and practice sets. Right, this is very important. So those who are interested, plus subscription, you have 3 chances: 12 months, 18 months, 24 months. This generally 12 months is the most popular one right now. So somebody who is targeting 2022 and 2023 is just registered here for 12 months. So the fee structure is going to be 27,225 rupees, 34,650 rupees for 18 months, and 39,600 rupees for 24 months. But don't forget to use this SVS10 as a code. SVS10 as a code. Okay, to get 10% off. 10% off. Next, for 12 months, you have a 45,225 rupees. For 24 months, you are going to have 66,600 rupees. 66,600 rupees. So again, you have a SVS10 as a promo code. So to get 10% discount. To get a 10% discount. Yeah. So these class notes will be posted in a Telegram channel. So I request all of you to join this Telegram channel called Unacademy Gate English. Unacademy Gate English. A Telegram channel is a Telegram channel where I am going to post my classes, class notes. And we have other YouTube channels also apart from the channel where I am teaching. I am teaching on a channel called Unacademy Gate English. Unacademy Gate English. So we have Creatrix Gate. We have Unacademy Gate for mechanical other branches. For civil engineering and chemical engineering also we have another channel. For computer science exclusively we have another channel. So for exclusive gate questions we have another channel, and for electrical engineering also, electrical junction also we have channel. So when you have time, just go to all these channels and see what they are discussing, okay. And so this is the January month schedule. So as examinations coming closer, so communications, engineering, mathematics, and analog electronics, these courses are targeting 2021. This 2021, and this target which are taught by Nageshwara sir, senior most faculty. Venkatakrishna sir also very senior faculty. Shravan sir is also senior faculty, and Venkatakrishna sir is also taking foundation course for 2022 and 2023 mathematics, right? So NLN Sharma sir is taking aptitude foundation course for 2022 2023, right? So even the students of 2021 can also listen to get benefit out of it, right? And we have Surendra Babu sir taking measurements, and Bhanu sir is taking electrical machines. So which is targeting for Genco, Transco, Discom, and AE and AWE, right? So don't miss all these classes. And I wish you again happy Kanuma. So tomorrow we'll catch up again. We'll try to solve more number of problems. As this is a festival season, I'm taking only 1 hour. So again from tomorrow I'll take 1.5 hours. Again from tomorrow I'll take 1.5 hour. Don't miss me to join at 3:30 p.m. tomorrow. 3:30 p.m. tomorrow, that is Saturday, right? So don't miss. This is a very important class. Tomorrow is a very important class. So what we discussed in the previous class, that will be implemented in the tomorrow's class. That is, we will try targeting all the problems, right? So that is very important. So thank you. Don't forget to like, and don't so if you like this session, please share with as many number of people as possible, and don't forget to subscribe this channel. Very important. Unacademy Gate English is going to be very big in coming days. And hit bell button. Okay, thank you all. We'll catch up tomorrow. Bye, good night.